In the first question it says the curve C is described by the parametric equations x equals to 3 cos t, y equals to cos 2t, and we have to convert this into Cartesian equation. Whenever you have to convert a parametric equation into a Cartesian equation, it is always important to have some sort of a connection between the two. One way of doing that connection is using a trigonometric identity. Now first let me write this out. X equals to 3 cos t. That means instead of cos t, I can send the 3 to the other side. I can write cos t equals to x by 3. And the next one is y equals to cos 2t. Cos 2t can be broken down as the double angle half angle formula. It can be written 1 minus 2 sine squared t. So 2 sine squared t equals to 1 minus y. Therefore sine squared t equals to 1 minus y by 2. We have found two values. One is cos t is x by 3, the other one is sine squared t is 1 minus y by 2. The identity that can be used is this one. Sine squared theta plus cos squared theta is identical to 1. This is an identity that first comes in C2. So what we can do here is we can write hence sine squared t plus cos squared t is identical to 1. Instead of sine squared t, I can plug in 1 minus y divided by 2 plus cos t is x by 3, so cos squared t is going to be x by 3 whole squared equals to 1. This is the Cartesian equation. This can be further simplified and we can have an expression of y in terms of x. So 1 minus y by 2 equals to x squared plus x squared by 9 equals to 1. So we can write 1 minus y by 2 equals to 1 minus x squared by 9. If we multiply by 2 to the other side, it will be 1 minus y 2 into 1 minus x squared by 9. So 1 minus y equals to 2 minus 2 by 9 x squared. So it would be y equals to 1 minus 2 plus 2 by 9 x squared. So 1 minus 2 is minus 1, so this would be 2 by 9 x squared minus 1. So this is actually a quadratic equation.